So again, page 357, we are going to graph y equals e to the x and y equals 3e to the x minus 2 plus 1. So I want you to figure out 2 points. You should be able to figure out 1 point really quickly on e to the x. 0, 1. Good. So if we're graphing e to the x, you have the point 0, 1. What's another point on e to the x? 1, e. Where is 1, e? Is it above 1 or is it below 1? If you don't know, find the number e on your calculator. 2.7 something. You're right. Find it on your calculator. What is the number e? 2.718. 2, 8, 1, 8, 2, 8, dot, dot, dot. But it doesn't continue with that pattern, even though it looks like it should. Okay, it's a weird number. Did you know that there were other weird numbers on your calculator other than pi? This is Euler's number, the number e. 2.71828. It is a very important number in calculus and in exponential functions. And so we may as well learn about it. Well, we will learn about it in this unit. So we start with e to the x, and 1, e will be above because it's about 2.7.
Sorry for the interruption. The track and field practice is canceled for tomorrow morning, Wednesday, May 4th. Thank you.
So that's what e to the x looks like. It's the same kind of idea as graphing 3 to the x or 4 to the x or 5 to the x. You still have 0, 1. And when you plug in 1, you have 1, e. It's just you have to know that e is about 2.7. I think on your formula sheet, don't have one handy, they might even have e on your formula sheet, so that if you forget that it's about 2.7, it's on there. Is it? Or did they take it off? No, it's not on there anymore. Okay, well, you just have to remember that it's 2.7. So now we take our points, 0, 1, 1, e, and our asymptote y equals 0, and do our transformations. First, take out my highlighter just like I've done before. My parent graph is e to the x. So the first thing I run into is the 3. That's going to multiply my y by 3. Is x going to get multiplied by anything? No. So we're going to have 0, 3 and 1, 3e. Next transformations, we are going to go right 2, up 1. Right 2, we'll take this to 2, and up 1 will 4. And here, right 2 will take it 3. How are we going to add 1 to 3e? We're going to write 3e plus 1. And now we graph. Oh, is anything going to happen to our asymptote? Do we ever move up or down? Yes, we move up 1. So our asymptote is at y equals 1. Start by graphing your asymptote. So So here we have y equals 1. Draw our points. We have 2, 4. That seems like a good point to start with. And we've got 3, 3e plus 1. Approximately where is 3e plus 1? It'll be 3 times 2.7 plus 1. It'll be like 9.1-ish. So I'm going to label it here 3, 3e plus 1. And if you had your calculator, you could get a decimal for that. But if this was a non-calculator question, you would label it as 3e plus 1. And now, since these two are decreasing here, it's going to go towards your asymptote and go up over here. And there is the graph of y equals 3e to the x plus minus 2 plus 1. Is it any more difficult to graph this than it was when the base was a nice number? Not really, other than it was more uncomfortable while doing it. Okay? So you could now, if you wanted to, you could do pi to the x if you wanted to. And you could do transformations with that as well. But unfortunately, pi isn't very helpful with exponential functions, but e is helpful with exponential functions. So that's where we're going to end for today.